Tires are often called the soul of movement, as they're the only part of a vehicle that actually touches the road. But have you ever wondered how a tire is actually made? In this video, we'll take you inside the fascinating process behind this unsung hero, from raw materials to the toughest tests in the industry. Before production, tire design is developed using digital models. Engineers calculate cross-sectional shape, ply structure, tread pattern, and rubber composition for ideal grip, durability, load capacity, and noise reduction. Each tire type requires a unique design, digitally simulated and virtually tested before physical manufacturing. If you find this fascinating, subscribe for more deep dives. A tire's journey begins with milky white sap from rubber trees. Skilled workers make precise cuts along the bark, just deep enough to reach latex channels without damaging the wood. Drop by drop, the latex falls into cups. Collected latex is mixed with ammonia to prevent coagulation, then transported to processing plants, where it's concentrated, rolled thin, and dried into sheets of natural rubber. Natural rubber alone isn't enough. To meet durability and abrasion resistance demands, it's blended with synthetic rubber. This stable material, developed through petrochemical processes, is created in labs via polymerization, linking small molecules from oil and natural gas. Synthetic rubber makes up over 60% of a modern tire, providing superior strength, cold resistance, and wear performance. The deep black color of tires isn't natural. Raw rubber is off-white. To create a strong automotive material, manufacturers blend natural and synthetic rubber, carbon black, softening oils, sulfur, and specialized additives. Over 30 components are measured and combined in massive industrial mixers under high heat and pressure. Carbon black improves durability, insulating oils maintain flexibility, and other additives fine-tune properties. This blend forms a thick jet black compound, flattened into sheets and cooled, building durability and elasticity into every layer. Building the core components begins with thick sheets of black rubber, flattened into thin layers and wound evenly, ensuring no air bubbles. Next, high-strength synthetic fabric is coated with molten rubber on both sides using a calendaring system, bonding tightly to each reinforcing fiber. Simultaneously, ultrafine steel wires are laid out in parallel and bonded to rubber with intense pressure, creating the tire's structural frame. This reinforcement maintains shape and performance at high speeds, managed by advanced technology for durability and safety. Once all components are ready, from the airtight rubber layer to the precisely aligned reinforcement fabrics and steel belts, the shaping process begins. On a large rotating metal drum, an automated assembly system kicks into action. Robotic arms move in sync, executing each task with extreme precision. Every parameter, from rolling pressure to rotation speed, is tightly controlled. The system maintains tolerances within 0.1 millimeters. Each rubber layer is applied to the drum by a servo-driven system, pressed tightly and aligned perfectly. 4 sensors and industrial cameras monitor every millimeter to prevent overlap or wrinkling, processing data in real time to adjust rotation and pressing force. As the raw structure is built, it's inflated with compressed air. Internal pressure causes the soft rubber shell to expand and conform precisely to its intended shape. This transforms separate materials into a unified, cohesive form. Pressure sensors monitor every subtle change. Any deformation halts the system for correction. In seconds, the basic tire shape is complete, ready for the next stage. In advanced factories, the tread is formed during vulcanization. The tire assembly is placed into a 2-piece metal mold, sealed tightly. Inside, intricate negative patterns define the tread design. The system heats the mold to 162-180 degrees Celsius, while compressed air or superheated fluid is pumped into a flexible bladder inside the tire, creating outward pressure. The softened rubber expands, pressing firmly into every groove of the mold, forming the final tread shape. This process lasts 10–15 minutes, triggering a chemical reaction between sulfur and polymer chains. Molecular bonds are reinforced, transforming the rubber from soft to a tough, elastic structure, critical for mechanical strength, heat resistance, road grip, and lifespan. After leaving the curing mold, tires are sent for rigorous quality inspection. Geometric measurements use laser beams to scan for roundness, alignment, and thickness. Slightest deviation disqualifies. Next, tires are mounted and inflated beyond normal pressure to check air retention and structural integrity. Leaks or abnormal deformation are flagged. Advanced facilities use X-ray technology to examine internal structure, detecting misaligned layers, hidden separations, or bonding defects. Only tires passing all tests receive an approval stamp, ready for the road. Billions of tires are discarded annually, piling in landfills. Unlike biodegradable materials, tires are nearly impossible to break down, containing synthetic rubber, oils, and heavy metals, posing long-term risks to soil, water, and air. Uncontrolled burning releases toxic gases, while degradation washes microplastics into waterways and the food chain. To address this, many countries use advanced recycling technologies, shredding waste tires into fine rubber granules. These are treated with heat, pressure, and chemicals to partially restore properties, typically used in new tire inner layers. Recycled material accounts for 10–20% of each new tire, reducing petrochemical dependence, cutting waste, and turning an environmental burden into a sustainable, circular solution. Beneath a simple layer of rubber lies a complex chain of technologies, precise to the smallest detail. The tire is the only point of contact between a multi-ton machine and the road, where motion, safety, and performance all begin. We hope this video gave you a new perspective. If you found it insightful, please subscribe to our channel and leave a comment. Your support helps us create more content.